Illustrative Math, Unit 3, Lesson 4 is called Positive Rational Exponents. So our goal is I can interpret exponents that are fractions, and I understand that b to the m over n is equal to the nth root of b to the m. So basically, what you need to take away from today's lesson is that if you have a fraction exponent, it's always going to be the power right there. See how it's m power over the root. So the n is in the bottom, so that's the root. Okay, so quick example. If I have 4 to the 3/2 power. Normally everybody would reach for their calculator right now, but you can do this without a calculator now if you understand that it's power over root. So I'm going to take 4 to the 3rd power and then square root. Now we don't normally write the 2 there. We know that it's a square root. Whoops. We know that it's a square root if we don't fill that in. We know that there's a 2 there. So now you can say, oh, 4 cubed. 4 times 4 times 4 is 64, and then the square root of 64 is 8. So you can do it without a calculator. And that's what your goal should be from today's lessons, to be able to do these powers, fractional powers, without a calculator. All right, find the value of each expression mentally. This is our warm-up. So we put these over 1, and we just multiply across. So 1 times 5 times 4 is 20. 2 times 1 times 1 is 2. So I get 10. Now, on this one, kind of the same thing. I could do 5 times 4 is 20. 2 times 1 is 2. Or here's another way you can do it. You can cross reduce. So 4 and 2 are both divisible by 2. So I make that a 1, make that a 2. So now it's 10 over 1, which is just 10. Same idea here. These, you can cross reduce anything. So the 3's cancel because one's the denominator, one's the numerator. And then same thing here with the 2's. The 2's cancel. So when they cancel, they all become 1. So in the top, it's 1 times 7 times 1 over 1, which would just be 7. Same idea here. These 3's reduce. So do these 7's because one's numerator, one's denominator. So anytime they cancel, they become 1. So the top is 1 times 5 times 1 over 1. There you go. Okay. All right, so here I have 5 to the 2/3. Okay, use exponent rules to explain why these expressions are equal to each other. So why are these two here equal? Well, exponent rules, algebra 1, if you have a to the m raised to the n, it equals a to the m times n. So you multiply. So this one here is going to be, let's go back to our fraction rules. Try not to use your calculator. 2 times 1, 1 times 3. So that's going to be 5 to the 2/3. And then same thing here. It's 2 times 1/3. Same thing. You get 5 to the 2/3. So I'm going to use this rule right here, multiply my powers, and I see that they're both equal. So write 5 to the 2/3 using radicals. Okay, so if you already kind of picked up on what I told you from the goal today, it's going to be 5, whoops, I'm sorry, not to the 3rd power. Top number is your power. The bottom number is your root. So I'm going to write this as 5 squared cubed root. Or I could say cubed root of 5 and square it. As long as the top number is a power and the bottom number is your root, you are good to go. So these are actually the same. If you type them both into your calculator, you get the same value. Why is that? Because let's go here. I'll come up here where I got a little room. 5 to the 1/3, that's the cubed root of 5. Times the cubed root of 5. And when I multiply these, 5 times 5 is 5 squared, and it's a cubed root. Okay, you keep the root the same. Don't multiply the roots. The roots will just stay as the cubed root. And the same thing over here, if I took this one, 5 squared, and the cubed root of 5 squared, because the 1/3 power means cubed root, it would look like that. So either way, you'll get the same answer. So 5 to the 4/3. So 5 to the 4th cubed root, or you could say cubed root of 5 to the 4th power. Okay, either one of those. You could also, if you wanted to, you could take 5 to the 4th, and I think it's 625. You could do that as well. So any one of those, they're all equivalent. Eventually, and this textbook doesn't do this very often, and this is a big thing that I don't like about this book. If I think of it like 5 to the 4th as 5 cubed times 5, because if you add those powers, you get 4, you could take the cubed root of 5 cubed, and that would be 5. And this is actually the best way to write them. But for whatever reason, illustrative math does not like to simplify radicals. On an ACT or SAT, it will probably be in simplified form. But anyways, all of these are equal. So should be able to do all of them. All right. All right. Complete the table as much as you can without using calculator. Should be able to fill in 3 spaces. Okay. So 2 to the 0 is 1. 2 to the 1st is 2. And then the last one here, 2 squared is 4. Plot the points you filled in. So x is 0, y is 1. X is 1, y is 2. And 2 is at 4. All right, so if I'm going to connect these, it's going to look something like that. All right, not very good. But should be a little curve, not a straight line. You can definitely tell that it's not a straight line, because if I do that, you can see that it's not a straight line. So you have to make it curved. All right, use the graph of, so we're going to say this graph here, and I apologize for it being so not smooth. Y equals 2 to the x. Use that to estimate the value of the powers in your table. So 2 to the 1/3. So it's going to be a little bit bigger. So I'm going to say, like, I don't know, 1.1 maybe. To the 2/3 looks like right here. So let's see, these go by, there's 4 of them. So every one of these is 0.25. So this would be 1.5 right there in the middle. So this looks like, I don't know, 1.25. 2 to the 4/3. So 4/3 looks like I'm right here. That looks like 2.5. 2 to the 5/3. That looks like 3. And then 4. Okay. So let's investigate it. Write 2 to the 1/3 in radical notation. So that's the cubed root of 2. What's 2 to the 1/3 cubed? 2 to the 1/3 cubed. Well, I'm going to multiply my powers. So 1/3 times 3 is 2. Raise your estimate from the table of 2 to the 1/3 to the 3rd power. What should it be? How close did you get? So I said 1.1. So if I take 1.1, take it to the 3rd power, let's see how close I was. Let me get my calculator out here. 1.1 to the 3rd. I was not very close. I got 1.331. So that would be my graph not being very good here. So let's do this. Let me redraw it, make it a little bit neater here. So 1 was at 2 and 2 was at 4. Let's see if I can do this here a little bit better. All right, a little bit better. So 1/3, maybe more like 1.2. Let's try that. What would 1.2 to the third be? Getting closer. It's definitely bigger. Let's try 1.25 to the third. Getting closer. If I do 1. Let's see here. 1.2 to the third was 1.728. Whoops. 1.25 to the third. And you can kind of trial and error it until you get it pretty close. All right, so it's obviously going to be like a little bit bigger than that. So, hard to tell here with this graph. So let's investigate 2 to the 2/3. So 2 to the 2/3, I got it right here at like 1.5. So write 2 to the 2/3 using radical notation. So power root, right? Or you could say cubed root of 2 squared. So if I cube it, you multiply, so it's 2/3 times 3. So I get 2 squared, which should be 4. So I said for 2 to the 2/3, let me go back here. This looks more like 1.5. I think it'll be a little bit more accurate here. Let's change that to 1.5. And let's take 1.5 to the third, because I basically said 2 to the 2/3 is approximately 1.5. So if I cube the 2 to the 2/3, I know it's going to be 4 because I did exponent rules. If I take 1.5 to the third, I get 3.375, which is not very close to 4. I know it should be 4. So obviously my graph is a little off. Okay. So I should get 4 because these should be equal, but obviously my graph is sloppy. All right. So lesson synthesis. What is the value of the 4th root of 9 squared? So 9 squared, 4th root. So think of it as the 4th root of 81. And that's going to be 3 times 3 times 3 times 3, 4 times. So it equals 3. Okay. Other ways you could look at it is you could say, okay, that's going to be 9 to the 2 over 4. Reduce it to 1/2. And 1/2 is square root. And you get there also. Okay. So express the number 16 as many ways as you can using exponents or roots. Now this one's kind of fun. So 4 squared. Let's see here. How about if I square root the 16, that would give me 4, and then square it, right? What if I did this? What if I took the square root of 4, and then, so the square root of 4 is 2, and then I'd have to take that to the 4th power, right? Let's see here. What if I did the cubed root of 8? That would get me to 2, and then I take it to the 4th power. So that's also going to be the same as saying power of 4 root of 3, so 8 to the 4/3. This is going to be actually the same. Well, this is going to be 4 squared because it'd be 4 over 2, which I already have. What if I said, what is 16 squared? 16 squared is 256. What if I just said the square root of 256, which is equal to 256 to the 1/2, because the power is 1, root is 2. All kinds of different ways that you could do this. So there's just a few. All right, what is 2 to the 5/3 raised to the 3rd power? Multiply. 5/3 times 3 is 5, so 2 to the 5th, which is 32. Right, 2 to the 5/3 using radical notation, so it's going to be the cubed root of 2 to the 5th power. Okay, the bottom number is your root, top number is your power. Or if you wanted to do it 2 to the 5th and then cube root it, that would work as well. What two whole number powers of 2 does 2 to the 5/3 come between? Okay, well, 5/3 is 1.67 approximately. So obviously I would say 1 and 2, okay, because 2 to the 1st is 2, 2 to the 2nd is 4, 2 to the 5/3 is somewhere between 2 and 4, okay? We can at least estimate it, get it close. All right, thank you for watching this video. Hope you enjoyed it.